Good morning. My name is Professor Mike Heimlich. I'm a professor here at Macquarie University. Hi! Professor in engineering at Macquarie University. My area of specialty is actually something called wireless engineering. I design integrated circuits that make this thing connect to the rest of the world. But what I'm going to talk to you about today is more along the line of robotics, and we'll get to that in a moment. The reason why I got into engineering is because when I was about your age, that was the time that people were first starting to walk on the moon and taking trips into outer space. And I thought that was just the coolest thing in the world, because at the time, that was sort of the peak of high tech. And I thought, I want to change the world just sort of the way that walking on the moon or flying in space is changing the world. So I decided to become an engineer. And some of the things I'll talk to you about today are little projects here and there where I've been involved in changing the world. I'll also talk about other ways that other people have changed the world and how you can change the world too by becoming an engineer. So first of all, I want to tell all of you that you're all cyborgs. Does everybody know what a cyborg is? You could shake your head if you know what a cyborg is. You've probably seen them in movies. Yep, a cyborg is a merger, or it's a combination of people and machines becoming one. And all of you may not consider yourselves cyborgs, but I'm going to prove to you here in a second that we've already become cyborgs, because we can't seem to go a moment without this little device here. Everywhere you go, you see people talking, you see people texting, you see people playing games. We can't live anymore without our smartphones or even our 2G phones to text and take phone calls. So it's already happened. We have stopped being just biological beings, and we become cyborgs, a combination of biological and machine-based life. And that might seem a little funny, but that's the world that we live in now, where people can't imagine not having their cell phone anymore. So with that in mind, I know maybe some of you can chime in and ask a question right away, but what's the coolest feature on your smartphone? Can some people chime in real quick? We'll give you about Games, okay. What else?
Touch recognition.
Touch recognition, yeah, okay. YouTube. Yep. Okay. Well, that's really good. All those things that you just mentioned in terms of working on a phone, when you were born, those things didn't exist. Those things are all new things in your lifetime. So before you were born, there was nobody playing games on a phone. There was no touch-sensitive phones. There were no touch-sensitive screens that worked real well, as a matter of fact. And the fact that I could use this as a GPS, or I could use it to monitor something going on in my body, just didn't happen with a phone before you were born. All that is brand new technology in your lifetime. And that's something that engineers have made happen. Okay, so that's sort of an introduction to my talk today. What we're going to go through in this talk is really the what, who, where, and how of engineers. And if you haven't guessed it already, I'm a pretty funny guy. Not necessarily because I'm a really great comedian and tell good jokes, but because I talk funny. If this were a really, if Australia was doing really, really well in terms of education, I would be here talking to you with an Australian accent. But the fact of the matter is that Australia only graduates half the engineers that the United States does. And the United States doesn't graduate enough engineers, so Australia's had to import people like me who talk funny to come here and be engineers. And that might not seem like such a big thing, because you might say, well, okay, if we don't have enough engineers, then we're not going to have as many games created in Australia, or we're not going to have as many new electronics invented in Australia, or we may not have all these car companies making cars in Australia. But the fact of the matter is that just having a modern first world society where every time you turn on the light you get electricity, every time you turn on the tap you get clean fresh water, every time you jump in your car you're guaranteed of driving on a road that may have 1 or 2 potholes, but it still works like a pretty good road. All those things require engineers, and when there aren't enough engineers, the lights don't always come on when you flip the switch, or they may go off after 4 hours and you have no idea when you're going to get more electricity that day. Or your water might not be so clean. Or when you flush the loo, it may not flush. And there's potholes in the highway, if there is a highway. And the trains certainly don't run on time, even if you're in Sydney and they run close to on time. So all those things require engineers. And if Australia doesn't have enough engineers, if some of you don't become engineers, then maybe when you have kids, the lights may not come on or the water may not be so clean. So it's very important that Australia creates enough of its own engineers so that we could stay the first world society that we are. And if you don't think that what I'm telling you is true, go visit some place like Argentina or Brazil or Pakistan, second world countries where they don't have enough engineers, and sometimes the lights go out and sometimes the water's not so clean, and maybe there's a big traffic jam in Sao Paulo, Brazil that takes you 3 hours to get to work each day. Okay, so I'm going to answer this question for you so we can save a little bit of time. But who do you follow in the news, in the media, and as heroes when you turn on the TV or read the paper or go online? I would imagine it's somebody in sports. So all the people who would follow folks in sports, could you shake your head? Or if you care about Angelina Jolie or Brad Pitt or One Direction or Katy Perry, music stars or people in the movies, who follows them? Hugh Jackman maybe? Yep. Maybe you're kind of plugged into world events. Yeah, I see that. Maybe you're kind of plugged into world events and you know who Tony Abbott is, or maybe Julia Gillard is a good role model if you're a girl and you want to grow up and be in politics or in government. Those are the typical people that we follow, or most Australians follow when they turn on the news or they go on the internet. Now another question, what are the biggest problems facing Australia and the world today? If somebody wants to chime in and answer that question, that'd be great. Poverty, that's a really good one. How about another one? What was that? Pollution. Okay. Some others would be, climate change or disease like cancer, or feeding 8 billion people going on 10 billion people in your lifetime. Those are some of the really big problems that Australia and the world face. But if you go and look at all the people we talked about a minute ago, who we follow in the media, who we follow on the internet, none of those people are going to actually come up with a solution for those problems. They might make that problem more popular and draw our attention to them. They may even help raise money to go solve that problem or make a law to help solve that problem. But the actual solution to those problems are not going to come from people in sports, people in the media, or politicians. The solutions to those big problems are going to come from engineers and scientists. So who's going to invent and innovate the solutions for those problems? It's the people that we're going to talk about in the rest of this presentation. Okay? So let's get to what do engineers do. I give this talk to a lot of different age groups, and according to the nice people at Bridges for Higher Education, I know we have some year 10s, maybe some year 8s and 9s, years 5s and 6 listening into this. I even give this presentation to kids in kindy, and when I go and visit those kids, they ask me, where's your train? Where's your locomotive? Because if I'm an engineer, surely I must have driven my train to come give this talk. And so they look out the window, where's the locomotive? Where's Mike's train? He must have it put in the parking lot someplace. And I have to explain to them that engineers don't just drive trains, or engineers actually don't drive trains anymore. But about 150 years ago, it required 2 or 3 engineers to drive a train. And the reason why is 150 years ago, a steam locomotive was the height of high technology. That was the most technically complex thing 150 years ago. So it didn't only take one engineer, it could sometimes take 2 or 3 to drive a train, because that was the most complicated thing that man had created at that time. That was sort of the internet, or the spaceship of its time, because it was so complicated. But over time, we've been able to make it much simpler, and what's complicated has become easy, and now engineers get to do other things besides take care of trains. So what are some of those other things? Okay, Well, the simple answer is engineers change the world, and we do it in your lifetime. When we started this talk, I talked about and asked you a question about all the amazing things that you can do with this little guy right here. And you told me about all these new technologies that have just been invented in your lifetime. Totally new technologies that didn't exist before you were born. And for any of you who are going to become engineers, it's going to be your job to invent those new technologies. So when you get out of uni as an engineer, probably in the first 5 to 10 years of your job, you're going to invent brand new technologies that didn't exist before. And you're going to change the world just in the first 5 or 10 years of your career. During the whole course of your career, and the government is telling us now that we're not going to get to retire, or you're not going to get to retire until you're 70, so you're going to work for about 45 years. During the course of your 45 years as an engineer, you're not going to only create one new kind of technology that totally changes everything. You're going to create 3, 4, or 5 brand new technologies that will wipe out all the technology that came before it in that area. So if you think about looking at cars in a movie that's from the 1960s and then looking at those cars in the 1980s, the cars have sort of changed a little bit, but they still look like a car. But if you look like cars today, they're somewhat very different with things like GPS and auto reverse parking and some amazing new technologies. You're going to create 4 or 5 technologies that are going to rewrite the books on automobiles, for example, or this little guy here. You'll rewrite the book 4 or 5 times on this guy and do amazing things like totally get rid of this, but embed it directly in our bodies or in our glasses, or somehow make us even bigger cyborgs than we already are. But that's what you're going to do, is you're going to reinvent the technology for something 3, 4, or 5 times during the course of your lifetime. Okay, so let's talk about some of the things that engineers do. We already talked about the mobile phone. So I give this talk to students coming into uni for the first time, and when they were born, the phone that they got to look at or use was this little guy over here. This guy over here, and the battery could barely last for a couple hours on that, and certainly there were no games, there was no texting, all you could do is make a call, and the call quality was pretty bad, to be honest. And now we have smartphones today, so just in the course of their lifetime, uni students, we've gone from terrible phone calls to having almost a whole computer on a phone. If we look in their lifetime over what was the height of computing technology, this guy over here is called a supercomputer. And back about 15 to 20 years ago, a supercomputer took up a whole room. And if you wanted to use one of these, you had to schedule time years in advance to be able to use it for a day or two. Or if you were the weatherman, maybe you could have one of these to help predict the weather. But it would take a whole room, a whole enormous computer to do that. Now, you'd be surprised if I told you today, this little guy over here, how many of you have one of those at home? How many of you want one of those at home? I don't have one. I want one really bad. Maybe I'll get it for Christmas this year. The computing power in a Wii is as much or greater than the computing power in one of these computers that took up a whole room less than 20 years ago. So in your living room, you have more computing power than an entire room's worth of computing did just 20 years ago. So if you have older brothers or sisters who are at uni now, that was the height of computing when they were born. Now you have that in your living room. That's how much engineers have changed computing just in less than one lifetime. This little guy here, does everybody know what that is? Does anybody know what that is? Do you have one of those in your house? If you have wireless at your home? Yeah, it's a wireless router. So that was actually invented by some really smart people at CSIRO, some people who make radio telescopes over there. And Australia is one of the leading countries in terms of radio telescope technology. But about 15 or 20 years ago, they had a little bit of free time, and they were sitting around the coffee room one day, or this is the way I imagine it happening. They were sitting around a room having a cup of coffee, and they were talking about this great new invention in 1995, 1998, called the Internet, the World Wide Web. Wouldn't it be great if we didn't have to plug into the wall with a cable to get on the World Wide Web? Wouldn't it be great if we could have our computer anywhere we went, our laptop, and we could connect to the World Wide Web? And so they decided to go solve that problem, and they did. They invented something called Wi-Fi. But these very smart guys didn't have the time to go off and build Wi-Fi because they were concentrating on building radio telescopes. So they came here to Macquarie University and found two of my mates, Dave Skellern and Neil Westy, and asked Dave and Neil if they could find some time to build the first Wi-Fi router, and they did. And so Macquarie University is known for building the first Wi-Fi system. And that's the group that I work in here. It's a world famous group, and so when the opportunity came up for somebody to be hired to work into it, I jumped at the chance to work in a group that invented Wi-Fi. I just thought that was the coolest thing in the world. And since then I've become friends with Dave and Neil, and they've actually helped me with some of my research. But they're the two guys who first implemented Wi-Fi, and that happened right here in Australia and right here at Macquarie University. Some engineering that's literally changed the world and the way we live. It's enabled us to become those cyborgs. It's enabled us to get everything out of these little devices that we enjoy today. Well, something else that's going on here today at Macquarie University is something we call the artificial robotic lung. And one of my colleagues, Dave Inglis, has invented this thing, and you can see it here on the right. I know it doesn't look like much, but this is actually a robotic lung, and what it allows us to do is mimic or imitate the action that our lungs take when we breathe in and out. So when we breathe out, our lungs collapse, and when we breathe in, they expand. And that's a really important bit of motion that doctors and people who develop new sorts of drugs would like to be able to study. But as you can imagine, it's really difficult to get somebody to help you test a new drug or to help you see what effects you would have if you breathed in some very dangerous chemicals or bacteria. So since we can't do those tests on real people, my friend David Inglis invented this robotic lung. And what it allows us to do is inject dangerous chemicals or new drugs or perhaps bacteria or viruses into the artificial lung and study what happens to them and how we could either beneficially use those drugs or new organisms to cure people's diseases, like maybe eat up their lung cancer or get rid of the asbestos that they may have breathed into their lungs, or to be able to study what effect dangerous substances might have without ever harming anybody. And that technology was invented right here, and it's being used today. Here's a picture that I took from David about some organisms that they are studying inside the artificial lung to see how they cling to the inside of a real lung, but they're doing it without hurting anybody and without any after effects in doing that testing. So that's some really cool stuff using robotics and technology here at Macquarie University, here in Australia, that engineers are doing today. And one of the things we're working on in the future is, does anybody know what this thing is here? Has anybody ever been inside of one of these? Yes, what is this?
Is it an MRI machine?
That's exactly right, a magnetic resonance imager. And you have to lay really still when you're inside one, and it takes a little while to take one picture after another, then it puts it together in a stack so that it looks like a 3D picture of you on the inside. That's brand new technology, again, from 20 years ago. One of the things we're working on now at Macquarie University is to take that wireless technology that we helped invent and combine it with a video camera, and combine it with a robot. We want to implant that into your body when you have an operation, so that instead of having to go and have an MRI being done after your operation to see if everything was fixed properly, this little robotic camera can roam inside of you and make sure that you were healed properly and that everything that the surgeon wanted to do was done. So that's exciting new technology that we're working on right now here at Macquarie University that combines wireless technology with robotics, video cameras, and hopefully before you're too old and you go and have some surgery, you'll have your little robotic camera inserted into your body, so you don't have to lay still for an MRI. You get pictures basically 24/7 of what's going on in your body without somebody having to cut you open again to see what's going on. All right. How do they get it out? That's a really good question. That's a really good question. So right now, if you were to have surgery, let's say, that would put some pins into your body because you have a severely broken bone, they have to open you up again to take the pins out. But there's some people in the United States and in England who are developing the ability to manufacture electronics onto materials that will dissolve inside your body and disappear. So basically, after about 3 to 6 months, this video camera and this wireless electronics will just dissolve, and it'll basically come out the next time that you have to use the bathroom. So hopefully they won't have to open you up again. But that's really very much futuristic stuff. Worst case, they just have to open you up one more time and take it out. You'll be all set. Or if it's really moving around your body, you can tell it to come to a convenient place just under your skin, and we can just take it out very easily, as if you were having a mole or a wart removed. Good question. Very good question. Okay, so that's sort of interesting, Mike, because that's what engineers work on. But what do engineers do? So, Mike, what do you do during the course of your day, or what would an engineer do in their career? Okay. So one of the things I have to tell you is that a lot of the notions and images that people have of what engineers do are wrong. I don't wear a hard hat. I don't use a drafting table. I don't wear a white lab coat. And I don't play with test tubes and liquids and things. There are engineers and scientists who do that, but the majority of us don't. So if you're at all concerned about having to wear a white lab coat and work in a special room that you have to go in and out of only certain times of the day, or let's say you don't want to wear a hard hat and work boots and steel-toed boots. You can do engineering and science and not have to do any of those things. And above all else, if you become an engineer or scientist, you do not have to act like Sheldon. Okay? We don't sit around all day doing rock, paper, scissors, lizard, Spock. We can, but we don't. All right, what do engineers do? Well, engineers basically are problem solvers. We design solutions to problems, but where engineering starts is with a problem. So the first thing that an engineer wants to do is ask why really well. And that's one of the things we concentrate on here at Macquarie University in our engineering program. We want our engineers to learn how to ask really good questions. Because if you can ask somebody a really good question, chances are you'll find out exactly what problem they're having, and then you can sort of develop from understanding that problem what the solution is. In other words, from asking good questions about the problem, you can come up with good solutions in terms of a design. So as engineers, we really ask a lot of good questions. And if you become an engineer, or even today, if you love puzzles or problems, or you like designing new things, chances are you might enjoy becoming an engineer. So some of the skills that engineers have, or some of the things that we look for in engineering, are not the things that you would think of. A lot of times when I ask people the question, what do you think an engineer needs to do or needs to know, they say, an engineer needs to be really good at math, or needs to love chemistry or physics. Well, those things help you be an engineer, but to be honest, the best engineers in the world are really good problem solvers. The best engineers in the world are actually really good at working in groups and communicating their ideas, because unlike maybe what you've seen in movies or on TV, engineering is not an individual event. It's not like swimming the 100 meters or running the marathon. Being an engineer is a team sport. It's more like cricket than it is like track and field. So engineers like to work in groups. Engineers like to talk about their ideas. Engineers like to problem solve, think up crazy ideas, and then knock them back until they get the one idea that's really going to work. That's what makes a really good engineer. So if you like working in groups, you like solving difficult problems, you like puzzles, you like asking good questions and getting to the bottom of a really good problem, you might be a good engineer. So let's play Who's an Engineer? How many people think this guy was an engineer? Albert Einstein. Thumbs up if he's an engineer, thumbs down if he's not. Well, Albert Einstein is actually known for the theory of relativity, which is a scientific theory in physics. Okay?
Okay.
So he would be a scientist. He wouldn't be an engineer. But one day, when Albert was done working with his buddies on relativity or other bits of physics, he wanted a cold drink, and he couldn't find one. So he and a few of his buddies actually invented the first practical refrigerator that could fit inside your house. Because before then, a refrigerator was something the size of a building. And the idea of having a refrigerator in somebody's house was just a crazy, ludicrous idea. But Albert and a couple of his buddies actually were the first ones to patent a small refrigerator that could fit into your home. So Albert Einstein is one of my engineering heroes for asking a really good question. Why can't we build a refrigerator that fits in a home? And coming up with a solution, designing a solution for that problem. Mythbusters, or any of the Mythbusters engineers. Thumbs up or thumbs down? Well, Jamie and Adam are special effects people. They're more artists. And I don't know what Tori and Carrie are. I'm not sure that they're engineers. They might be tradies. But it turns out that Grant Imahara is an engineer. And he actually went to the university I went to as an engineer. So I'm kind of proud of Grant. But Grant is a graduated engineer. He uses all that engineering knowledge to ask good questions about what they want to do with that certain myth that they're going to bust and design a solution. That's why he's always doing the robotics, and he's always coming up with those really fancy, well-engineered approaches to things. Everybody know him, Mr. Bean? Is he an engineer? He's certainly great at engineering laughs. And he certainly develops a good comedy. So thumbs up or thumbs down? Well, it turns out that Roland Atkinson has a Bachelor of Engineering degree from Oxford. So I don't know what they're doing over there in England. But he managed to get an engineering degree, and now he's making the rest of the world laugh. I would imagine that he's really good at solving the problem of what's funny in the 21st century. And I think if you've seen his movies and TV shows, he does a very good job of it. Finally, I want to convince you that you can be engineers. So here at Macquarie University, we do something called First Robotics. If you go to ozfll.org, you can see some First Robotics for primary school. If you go to www.thunderdownunder.org, you can see some robotics for high school students. But this is a program where students have basically 10 weeks to start with a good problem and come up at the end of 10 weeks with a robotic solution to that problem. So for the first robotics competition, for example, 2 years ago, the problem was design a robot to play a 3-on-3 game of basketball. And last year, the game that we had to solve for the first robotics was to play a 3-on-3 game of ultimate frisbee. In FLL this year, students have to navigate a tabletop filled with different Lego bits that solves problems related to natural disasters like tsunamis or earthquakes. And a question just popped up. I thought. Yeah. Great. So if you want more information about how you can be an engineer today by doing the first robotics program, go to one of those two websites. And so we have a group of students here at Macquarie University, high school students who come here from all over Sydney. There are about 35 or 40 high schools represented on this one team who come here every Friday night from 6 to 9 p.m. Everybody's welcome. So if you're within driving distance or within distance from the train, you're welcome to join us. If not, contact me and we'll help you get a team set up anywhere. We have teams all over Australia, even one about an hour and a half south of Darwin. So it's not impossible to have a team anywhere. We'll help you set up a team, and you can be an engineer by designing a robot in 10 weeks' time. What some of those students have decided to do in addition to building their own robot is the skills that they've learned as engineers, they're now turning around and helping people here in Sydney. One of the projects that they're working on is with an organization called TAD-NSW, or Technical Aids for the Disabled, where they're building a special chair for a woman with a neuromuscular disease. Her muscles aren't strong enough to help her get up and out of a chair. So they're building a custom chair that works exactly the way her legs would have to work to get her up and down into the chair, including swiveling around her desk location. So that what they've learned to do in terms of building a robot for fun, they're now applying to solve a real problem for a real person. It's going to make a big difference in this one lady's life. And they're having a great time doing it. A question?
How can
Yes, we can talk more about that offline because it's about a 5-minute conversation. You can get my phone number from the person working the keyboard here, and we'll get in touch with you later today if you want, because we can get you going in time for next year's season. There's already a lot of FLL going on in Wollongong. It's a hotbed of FLL, but there's nobody doing the bigger robots yet. We'd love to get somebody going down there. Just because Wollongong's doing so well with the Lego robotics. All right, so the final question is how we do. How do you get to do engineering at Macquarie or any university for that matter? Well, the easiest way is to take some maths and take some science, but really focus in on that creative thinking and problem solving. Try to do a year 10 experience that gets you into a company or a university that has engineering or science, and start working on problems like that. The other way that you can get into university for engineering is to do the first robotics program. We actually have a direct entry program into our engineering program here at Macquarie based on your experience for first robotics. So if you can go and be on a team and demonstrate that you know how to design using the computer tools that we have, and you know how to build using the machine tools that we have, and you know how to program the languages that it takes to control these robots, then if you do that really well and demonstrate that you can work in a group on these significant engineering problems, then we have a spot here at Macquarie University for you to study engineering. I don't want to say regardless of how you do on the HSC, but if you don't do so well on the HSC, these things can take the place of a really high ATAR or supplement your ATAR to get you into an engineering program. And there's other universities that do similar things. I don't want to make you just have to come here. But if you demonstrate in your high school experience that you're a good problem solver, a hard worker, you work well in groups, then chances are there's an engineering program someplace in Australia that's looking for you to study engineering at the university level.
Question from Liz. Have you ever done robot wrestling?
Well, the robotics tournaments that I tend to get involved in, we try not to have the robots hurt each other because an awful lot of work goes into them, and in some cases a bit of money as well. And it would be a shame if we walked away from a competition and we didn't have our robot working, because that was the whole aim of the competition, was to hurt one robot or to get one robot, let's say, pinned down or less functional, let's say, than another robot. What we try to do is compete like crazy, and we don't try to beat the other team. We try to see if we have built a robot that does everything we thought it could do. So we try not to have the robots hurt each other, or definitely not have the robots hurt people. But we try to make the robots play a fun game rather than a destructive or combative game. I know you've probably seen Robot Wars, but yeah, we don't do that. We want high schools to enjoy robotics, not to pick up the pieces after robotics. Good question, though. Okay, so for engineering, it's all about changing the world, and in your lifetime, engineers are going to change the world 3, 4, or 5 times over. It's an exciting career because you're always doing something new, and it's all about problem solving and being creative. So come change the world with us. We're looking forward to having you be here. Thanks very much. I think we have about 5 minutes for questions. Humanoid robots are really, really difficult to build. And one of the reasons why is that if you try to make a machine do the things that a human does, it doesn't map really well. The things that machines are good at doing are different than the things that people are good at doing. So things like balancing or standing on one foot and kicking a ball is a really, really difficult problem to solve. And in many cases, it doesn't have a good application, let's say. We enjoy watching people play soccer because of the fun and skill of us being able to do it. I'm not sure how much fun it would be if we replaced all the World Cup soccer players with robots. Now, that being said, we do design robots to do things that people do. One of the biggest applications right now for robots is robotic surgeons, so that a robot would actually be cutting or doing the surgery on somebody with the doctor in a remote location. So if we needed to have somebody in the outback, let's say have open heart surgery, and we couldn't fly them to Sydney, Melbourne, or Perth, we could have this robotic operating theater do the actual cutting or the actual surgery, and the doctor would be someplace else. But that robot doesn't look like a person at all. That robot looks like a huge cylinder that has all these attachments going onto the person and all these wires coming out of it. It looks anything but like a person. So when we design robots to do things that people do, most of the time we don't have it look like a person.
Question from Kanahuka High School. What types of things do you build robots from?
Oh, that's another good question. So today, most of the things we build robots from are things that you would find technically in your car, as odd as that sounds. If you take all the components that are in your car, the engine aside, things like electric motors, things like pneumatics or air-powered things or hydraulic things, that's pretty much what robots are made of. The heart of a robot, if you will, or the brain of a robot is a computer. It's a special computer that we call a microcontroller. And unlike the computer that you might be familiar with in your classroom or in your mobile phone, the microcontrollers that we use for robots have a lot of connections to them because we need to control many things. We need to control an arm or some sort of actuator, or we need to sense things. We need to take input. So we want to see how bright it is in a room, or we want to know when we rotate our cell phone or when we touch something. So the microcontrollers have a computer at their very heart, but this microcontroller is surrounded by a lot of what we call I/O ports that are able to communicate very quickly and efficiently with a high number of things in the outside world. So robots today would be built from things that you're familiar with: motors, actuators, sensors, and a computer. Yes, as a matter of fact, I have. One of the competitions we did for First Robotics was called Overdrive, and it was mimicking a NASCAR racetrack in the US. So we had to run around this racetrack with robots, and I'll tell you, some of those robots, they're powered by a car battery. They would get up to 50, 60, 70 Ks an hour. And while we were driving around this racetrack, we had to manipulate a 1 meter size ball and throw it over the start-finish line every time we crossed. So it wasn't just racing around the track at 50 Ks, it was picking up a 1 meter size ball and throwing it across the start-finish line every time you went around. Pretty crazy game, but that's how complicated the robots are that high school students are able to build year after year. My favorite type of robotics is robotics that students do, and the reason why is all of you have much more wild and crazy ideas than I will ever have. One of the great things about young people doing engineering is that you don't have any notion yet of what you can't do. If you told me that you want to build a robot that can hover over the ground and move large objects all day long without recharging the battery and play music at the same time and do 5 other things, I would come up with 6 or 7 reasons why that's impossible before you even started. Whereas you would just go off and try to build that, and you would wind up proving me wrong for all sorts of reasons. So I love the robots that young people build, because before they build them, if they were to tell me about it, because I've seen everything or I know too much, I would come up with really bad reasons why it wouldn't work. But you're going to actually do it. You're going to prove me wrong. And I can't tell you how many times I've been proven wrong. And I love being proven wrong, because that means that some great innovation, some great idea, some great problem has been solved that me and my generation would not have been able to solve. And that's why I get really excited about working with young people on robotics, because you guys are constantly proving me wrong, and I love it. I love being proved wrong. I want to see all of you prove me wrong today, tomorrow, and 10 years from now. So I think we're about out of time. I want to thank you all for your attention. The questions were fabulous. I wish we had another half hour to do this. I wish I could come to all your classrooms with robots and see the robots that you would build with some of the programs that we have. But again, if you're interested at all, have your teacher contact the Bridges for Higher Education people, and they'll get you the information that you need. Thanks so much, everybody. Best of luck to all you, and I hope we get a whole heap load of engineers out of this today.